Okay, we are back, and today we are looking at estimating the square root of a number. Now, I alluded to this at the end of the last lesson. I dropped a little foreshadowing that this is kind of where we were going, and we used an awesome tool. So let's take a look at a slightly different way. Now, if you recall, last time we used this tool right here, and so I was saying that when you're dragging it out, it's going to tell you the area. And if you remember the area, that's just side times side. So if we are looking for, say, the square root of 49, we can look at our side length and we know that it's 7. If we're looking up to 8, we know that 8 times 8 over here is going to be 64. That's our perfect square. So when we're in between, this is kind of visually letting you do it. So if I'm looking for, like, say, the square root of 53.5, I'm like, okay, it's 7. It's a little less than half, maybe like 7.3. Or if maybe I was up here and I was trying to think about, okay, what's the square root of 60.8? Okay, it's just a little less than 8, so maybe 7.8, 7.9. I can estimate using that. We're going to look at a different tool today, but if you want to use that, by all means, it's awesome. I'll link it again in the notes at the bottom. So let's pull up right here. So if we are looking for the square root of a number, it's the factor of the number that's multiplied by itself. So the square root of 16 is 4 because 4 times 4 equals 16. We're going to be on a roll for neat penmanship today. We'll see how it goes. So if we're going to estimate, we're looking at perfect squares and using them as what we call benchmarks. So benchmarks are like, give us the base for where we're going to start. So if we've got we can use this benchmark chart right here. It's pretty useful. And we see the square root and the squares on top. So 2 times 2 is 4, and the square root of 4 is 2. Same thing way over here. 13 times 13 is 169. The square root of 169 is 13. So if that, I'll just draw those in there. Okay. So hopefully that kind of helps make a little bit of sense. So let's look at this briefly. The square root of 10, if we look up here, where would 10 be? It would be in between 9 and 16. So it would be between 3 and 4. Hopefully this makes sense. It makes sense. You can use, again, visually go back to that chart, to that interactive, and it works pretty well. So in between 3 and 4, but if we think about 10 is pretty close to 9, so it's going to be closer to 3, so I might estimate it at 3.1. If I'm looking at the square root of 44, where would that be? 44 fits in between 36 and 49. So if I'm looking in me here and I think about 44, 44 is pretty close to the middle. 36 to 40, that's 4, and then there's 9, so it's pretty close, maybe a little bit over there. So I'm thinking about, maybe 6.5, because on the bottom it would be halfway in between those, maybe a little bit over 6.6 maybe. So if we want to be more accurate than just kind of like thinking like that, we can use a number line. So let's roll through an example on using a number line. So if we think about this, we're looking for the square root of 28. So we know that the perfect squares on the lower side, again, you can use our chart right here. I'll leave this chart up here and I'll throw me up top. Actually, I'll throw me on this side. So we see 25 is a perfect square and 36 is a perfect square, and the square root of 25 is 5, square root of 36 is 6. So 28 is going to be somewhere in between. So we could use a number line to draw this out. So let's look a little more closely. So if we had 25, we'd have 26, the square root of 26, square root of 27, square root of 28, square root of 29, square root of 30, square root of 31, square root of 32. You get the point, right? Square root of 33, square root of 34, square root of 35. Now, I didn't space these out perfectly in the number line, but that's okay. We're thinking more on the number of items in here than exact perfection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of those. So half of 10 would be 5. 1, 2, 3, 4, 5. So right in between here would be half, even though it's, kind of off from half, but that's okay. So what number am I looking for? I'm looking for 28. So my 28 is right here. So half of between 5 and 6 would be 5.5. Okay, so if I went in between here and if I look, there's 5 and it's number 3. So it's right in the middle. So half of 5.5 would be 2.5. Oh, sorry. 5.25. So that's going to be my estimate. I'm going to go with that. I'm going to estimate to 2 decimal spots to 5.25 is the square root of 28. Let's try it one more time right in here. Now, this time, I'm going to pause the video and I'm going to write all these in. And while I do that, you pause the video and try it out on your own. And we'll meet back here in just a second. Phew, that took a while. Now we're back. So I looked at my chart and I saw, okay, so I've got 49 is on the low end and 64 is on the high end of this as our perfect squares. I know that the square root of 49 is 7 and the square root of 64 is 8. So this number is going to be somewhere in between there. So let's count my numbers. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Half of 14. 1, 2, 3, 4, 5, 6, 7. Again, I didn't quite make it even. 1, 2, 3, 4, 5, 6, 7. That's okay. Half of that is going to be 7.5. So what number am I looking for? I'm looking for 55. 55 is right here. It's really close to 7.5. So I might estimate that out as 7.4. If I was looking for the square root of 58, it would be on the other side, but still a little less. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Still a little bit less than half. So I might label that as like 7.7. 7.6, somewhere in there. Okay, so we're using our number line to estimate out where we are at.